Hey guys, this is Dan, and today we will be going over discussion 1, and specifically we'll be going over the isPrime function. So why don't we get started? So first of all, what is an isPrime function? Well, it says here that it returns true if n is prime and false otherwise. But what does that really mean? So I guess the first step we can take is to figure out what a prime number really is. So what is a prime number? I'm sure that we all know that a prime number is a number that has exactly two factors. So 11 would be a prime number, but 4 wouldn't be a prime number, because 11 has factors 1 and 11, and 4 has factors 1, 2, and 4. Okay, so now that we know the definition of a prime number, how do we use that to figure out our function? How can we tell whether or not a number is prime? Well, I implemented some functions over here to try to flesh that out for us. So the function is called solve prime. So if I do solve prime, it will tell me whether or not the number is prime and what are the factors. So if I do solve prime of 2, solve prime of 3, solve prime of 4, 9, solve prime of 10. So these are just examples. So over here I asked my function, oh, is 10 prime? No, 10 is not prime. And why is 10 not prime? It has factors other than 1 in itself. It has 2 and 5. 9, is that false? Yes, 9 is not prime. It has the factor 3, which is not 1 in itself. So that's how we can tell whether or not a number is prime or not systematically. We check whether or not it is factored other than 1 in itself. Another key thing to notice here is that all the factors are bounded by the actual number. So the factors of 10 has to be less than 10 or 10. It has to be less than or equal to 10. So that's another important fact that we will incorporate later into our code writing. Okay, so what I did before this point is pretty much what I do before I think about implementing a function. I try to think about what is the function trying to do, and I try to run through some examples in my head. So over here, if you want to figure out whether or not a number is prime, you have to look at the factors, right? And then if it has too many factors, then you're like, oh, that number is not prime. But if it has exactly 2 factors, you're like, oh, that number is prime. So why don't we hop into writing the function itself? So over here, I already started a doc where we can write our function. Well, let's jump right into it. Okay, so let's get coding, guys. So how do we know whether a number is prime or not? So we can tell whether it's prime or not if it has factors, right? But not just any factors. Factors that are not 1 in itself. So when we're checking for factors, we would like to check for factors that are not 1 in itself. So that means somewhere in my while loop, I would like maybe something like possible factor is less than n, because we don't want our while loop running into n. So this like excludes n. And we also don't want our possible factor. So possible is equal to one number. What do we want to start our iteration through? Well, we could start at 1, but 1 is a factor of everything. And if we start there, then our isPrime is always going to return false. So let's try to start with 2. So how do we check whether or not a number is a factor of another? So if we look back in the beginning, we can use the mod operator. So essentially what mod does is that mod tells you the remainder of a number. And you can tell if a number is a factor of another if the remainder is 0. For instance, 4 mod 2, so 4 divided by 2 is equal to 2, so the remainder is 0. So if the remainder is 0, 2 is a factor of 4. So I'm going to try to implement that logic in a more general case. So if n mod possible is equal to 0. So if it is a factor of n, then what do we want to do? Well, if it is a factor, then it is not a prime number, right? Then we would want to return false. But what if it doesn't return false? Let's say we were doing is 9 prime. Well, we're going to go through the case of the number 2. Then we're going to want to move to the number 3, right? Because 3 is a factor. So we're going to want to increment possible by 1. And yeah, so we keep on going until we get up to n without doing n. So let's say we're doing is prime of 23. So pretty much our case is going to run through like, oh, possible, it's less than 23, and then it will never get in here because 2 doesn't divide by 23 divided by 2. The remainder of that is not equal to 0. And then 3 is not a factor of 23, and then 4 is not a factor all the way up to 22. So when that happens, when it can run through the entire scheme of numbers, then we know the number is prime, right? We know it is prime. Okay, so I guess the last thing we'll have to figure out is that, what if for the corner or edge case, that n is equal to 1? If n is equal to 1, we'll jump here, it'll go past this while loop and return true. But we all know that 1 is not a prime number, so we're just going to have to catch that case. So if n is equal to 1, we would like to return false, because 1 is not a prime number. Its only factor is 1. And I hope you learned a lot from this, and good luck coding.